So, good morning, everyone. My name is Oleg Ishchuk. I am in charge of operations at SDC Verifier, and we are happy to present to you the new advancements in SDC Verifier 2024 R1, our latest release, which just became public. It is already available on SDC Verifier website. So after this presentation or during this presentation, please head to our website and download the newest version of SDC Verifier, either in its standalone interface or in interfaces for Ansys, Femap, and Simcenter 3D. A quick agenda and quick overview. What are we going to speak about today? So we will speak about some new codes in SDC Verifier. We will describe new features, new tools, improvements of the interfaces and tools, and new opportunities for you, of course. SDC Verifier in its standalone version has been updated among the other interfaces for finite element analysis tools. So everything I'm going to show to you today, unless it's highlighted separately, is available for everything, for SDC Verifier in the independent standalone interface, for SDC for Ansys 2024-1, SDC for Femap 2401, and SDC latest Simcenter 3D, SDC for Simcenter 3D 2023-12. The interface of the software has undergone minor changes and small updates and improvements. So in the graphical interface of independent standalone version, you could see more options on the ribbon on top for adding, hiding the properties, geometries, elements, and any graphical items, as well as possibilities to show and hide certain stuff, as well as possibilities to show the elements with colors, thicknesses, different graphical options. Also the possibility of multi-selecting in the project tree and extra functionalities in the ribbon. In the versions for Ansys, Femap, and Simcenter 3D, the main window of the interface remains the same. The tree, so everything on top and in the tree has undergone the same changes and works in the same way as it worked before with the FEA tools. So one of the core things in SDC Verifier is obviously our standards list. So we are going to start from that, and SDC Verifier in this release has extended library of 5 more standards. So now I am going to walk you through those standards and show you what have been added in terms of code checks. Let's start with the updates. SDC Verifier implementation of ABS, American Bureau of Shipping rules, has been extended. So one of the codes is plate buckling requirements for offshore structures. So ABS for offshore structures version of July 2022 has been added. The interface of the standard is pretty similar to what we have had before. There is a possibility to define the maximum allowable strength utilization factor, which is inverted safety factor, the functionality to multiply or reduce the thicknesses with certain factors, and our standard possibility to use plate average stresses or elemental stresses on for the plate buckling. So functionality is the same to the code that we had of 2002, I believe, and there is also a comparison of all the new version. In terms of results, almost nothing have changed, but now you can also comply with the latest version. And speaking about the latest versions, the most up-to-date code for floating production installations of American Bureau of Shipping of January 2024, another plate buckling code has been added to the interface as well. So the code was just released in January this year, so 2 months ago, and we have already added this code to the functionality of SDC Verifier. The interface and idea is pretty much the same as for all of our plate buckling codes: possibility to define safety factors, thickness factors, and PR for the materials, and then decide what kind of stresses you want to use and for which sections and plates you would like to run the plate buckling checks. So 2 more and 2 new standards for the plate buckling. Now, one of completely new and fully so fresh from start, and also new logo in the library of standards. I must say that this is one of the most long-awaited rules in SDC Verifier. A lot of customers in the past year and recently have been asking us about adding plate buckling assessment of Bureau Veritas. So BVNR 615 has been added to the library in this version. You can and it enhances our library of plate buckling according to Eurocode, DNV, ABS, now with also rules of Bureau Veritas. Again, in terms of functionality, plate buckling codes are relatively simple. All the magic is done by SDC Verifier's automatic recognition of panels and plates. So everything that user has to do is to select the plates which he or she would like to have checked, and select the thickness factor, safety factor, and the method to read the stresses, and the checks are run automatically, and the buckling factor is identified, is calculated and presented for each and every plate of your FEA model. Extending our library of codes even more, we have added Australian standard, new Australian standard AS4100, so 4100 4100 of 2020. It is, as far as I am aware, it is replacing the standard that was already in our library, AS3990. Now we have AS4100, which is a beam member design check, and multiple of failure modes for this check has been implemented. So sections 5, 6, 7, 8, and combined, I believe, section 11 have been implemented. So for axial tension, compression, bending, shear, and all the combined actions. Also for multiple different cross sections and element types, so channels, circular tubes, any type of tubes or pipes, basically, and then circular and rectangular bars. This is enhancing our presence in Australia. Our customers in Australia are very happy to have this in the libraries and to be able to use this, as well as this code is commonly used in Asia, in multiple countries around the world. So I believe this is also a valuable addition to the library of standards in SDC Verifier. Furthermore, specific standard which was requested from one of our big customers and long-term customers who needed to perform, to have a possibility to do the checks of welded connections on 1D model. So when you're having a very big model and you're not able to run the detailed checks, so far we have had weld strength checks in SDC Verifier. We have had them only on 2D or 3D elements, so it was necessary to run the automatic weld recognition to define the welds, to reorient the stresses into the weld directions, to assign classifications, and then run the analysis, which will showcase you the specific weld which is failing and utilization factor for that welds, and so on. Some of our customers are in need of checking the welds for 1D models, where there is only a connection of 1D elements of a specific type. So it can be different type of joints for I-beams and rectangular hollow sections, where just the size of the weld and type of the weld has to be defined. So software is automatically defining these connections. User has a convenient interface to define the weld type and the weld size. And after this is done, it is possible to get the utilization factor for welds on that specific connection. So if you're running beam models, 1D models, and you are in need of weld checks on those models, we now have that. So weld strength is possible for 1D elements, 2D elements, 3D elements. Doesn't matter how your finite element model is built. We're able to run the weld checks on all of them. And this is a big enhancement. You don't have to advance in the in modeling from the early stage of the project. You can keep it simple with beams, identify those which are subjected to be overstressed or overloaded, then go into submodeling only with the details which are really necessary and really important for your analysis. And this wraps up the addition of the standards. So 5 more standards in this half a year stint for SDC Verifier. A lot of advancements in plate buckling, ABS, 2 codes of ABS, 1 of the Bureau Veritas, beam member checks for Australian standard, and welds on 1D elements for Eurocode3. Often when we are speaking about standards, I get the question, how do you prove that your analysis is correct and your calculations are correct, and that the results that we are getting are the right ones? First and foremost, our results are proven by numerous customers of SDC Verifier who are submitting their calculation reports to classification societies, customers building structures with SDC, and giving their feedback and comments to us. But obviously this is not enough. So we are at least twice. So before publishing the new standard, we are checking it at least twice with different benchmarks. And a lot of those benchmarks are now publicly available on the website of SDC Verifier. So this is an example for AS4100. As you can see, 7 different examples for different type of members has been checked. And if you go to our website, you'll see this article, you'll see this detailed document, which shows, okay, this is the example which was taken from the standard. This is the parameters of the model that were taken from the standard, the formulas we had to follow, and then the value inside of the example and the value in SDC Verifier. So the same of, it's all highlighted, it's all shown in different colors to indicate and highlight what is possible and what are the results, and that they are identically matching. Let's go through some features that are now available in SDC Verifier. So you may have known that we have the Rainflow Counting method to run the fatigue checks. Rainflow counting is very important, and lots of users have asked us for this. And this year we did further advancements with rainflow counting. So it is used to determine the number of fatigue cycles, and it's based on load time history. It's used to reduce the spectrum of the load variation and to bucket your stresses into a set of simple reversals. This tool was in SDC Verifier for quite some time. This year we updated performance, but we have also included a possibility to run the checks of rainflow counting on multiple fatigue standards. So now in the interfaces of standards, of fatigue standards of SDC Verifier, at the bottom, you will see this small window which allows the user to include or exclude the rainflow counting and to and to select the method for calculating the cycles. Then the load groups of those cycles calculated with Rainflow Counting method will be used for the standard. So further enhancements to all of the fatigue standards in SDC Verifier. You can, if you remember from the previous version, we have added the possibility to use or not the hotspot stresses. So now in SDC Verifier, when you're creating a fatigue standards, you can use nominal stresses on elements for fatigue with dedicated SN curves, and then the same you can do with Rainflow Counting. You can either use the load groups from which you have created manually, or you can define all of your loading conditions, run the Rainflow Counting tool, and define the stress groups to have the most correct and precise results and dedicated stress ranges using Rainflow Counting method. I think we will soon release a detailed tutorial video, which will be explaining the calculation details and the interface for this tool and for the Rainflow Counting method. Extra advancements for the welds. Now by default, there is Elemental-Nodal method in weld force summation, which is replacing our previous nodal method for all the weld strength checks and weld strength standards, such as Eurocode3, D&V weld strengths, and so on. So this method is not only taking the forces from nodes, but it's summarizing the forces at each welded node from respective weld part elements. Besides the weld lengths and the coordinate systems, they are calculated for each weld, and they are taking into account the neighboring elements. And then the weld length is a sum of the half of the length of vector between the adjusted weld nodes, as you can see on this picture on your screen. So for this node, the length is taken from here till here. And this method calculates the coordinate system at each node. The averaged vectors from the neighbor elements are used, which allows even better precision and even better results for the weld strengths. Okay. Now some of the options that has been added in SDC Verifier in its standalone interface. It's a possibility to select the different analysis options. So when you are creating a job to be analyzed, you can have a further control over the options of analysis and select either static analysis, normal modes analysis, buckling analysis, nonlinear, and so on. So small advancements in terms of calculation settings and adding the functionality for defining the analysis options. Also, all of the parameters to identify which stresses to calculate, which results to request and to write into OP2 file, as well as definition of analysis selection, analysis results, and further has been added. Now, one very interesting feature that we are eager to advance on, and we would like to hear your feedback about, we want to implement more and more of modeling automation into SDC Verifier. As you may have known or used, we have some tools for parametric modeling of beam models, as well as definition of parametric crane. In this version, we have added a possibility to, besides all of the import possibilities of obviously FEA interfaces as Ansys, Femap, Simcenter, the import capabilities of SDC Verifier in the standalone interface and mode, we have added the possibility to import the file, what we call file to model. So there is the interface. Some of the code checking, dedicated code checking tools, FEA tools, and simulation interfaces are having possibility to export the the parameters of model and results into files. And we have this interface now to import the models from file. As you can see on this interface, there are separate files to be selected for materials, properties, points, and geometry. And templates can be copied, and templates can be stored within your at your computer to adjust and define. But it also reads standard parameters from other main code checking software, so to say. So I have here a short video explaining the interface of this. We are going to scroll through this video, I think, a bit, and to the possibility when you're clicking on copy templates is you will have a list of documents that you can select and then define the parameters. So when you have the files on your computer with this new model parameters, you then just go to the interface, select materials, select the file with material, select the file with properties, with points and lines. And after this is done, you click on create, then the calculation, the modeling process starts. This is quite an extensive model, so I'm going to scroll this a bit. On the background, you also see when geometry is when the model is created. And after it is done, SDC Verifier is asking you to give a name for your new model. You're pressing OK, and the model has been created. After, so what do you have in this model is the full geometry of lines and definition of properties and materials. So when you turn on the thickness, you can see that for this electrical tower, every property is defined, every material is defined, and all the mesh is built and it's all connected. So your model is ready for applying the loading conditions, applying the boundary conditions, applying running the analysis, and it's basically ready for simulation. As I said, we are extremely interested in developing these tools. We want to simplify the modeling for you as much as possible. This was, by the way, done on a specific request of a customer who had a need to import the models from one interface to another, from one type of tools to another, and it saves. So the generation of this model was maybe a minute or a minute and a half, compared to, I don't know, a couple of days of manual modeling. So if you have repetitive modeling tasks and complex models that you that are able you're able to have parameterized, let us know. We will gladly help you with automation of those modeling. This feature is available in SDC for Femap and SDC Verifier independent interface so far. So there is a slight limitation in terms of interfaces in which you are able to use that. Let's go with further improvements and extra additions to the software that have been done. Some improvements in formulas for Eurocode3 member check and American Bureau of Shipping floating production installations plate buckling standard have been done. Also, we have added the possibility of a multi-select in the project tree of SDC Verifier. I don't know if you have noticed, but in the previous version, it was possible either to select one by one or by clicking on full parent chapter right button to edit multiple. Now it's also possible to select multiple items of different items or sub items to further have them copied, removed, modified, edited, and so on. So slight improvement, but in terms of interface, but big improvement in terms of convenience and functionality and possibilities of the software. Also, we have improved the performance of predefined load combinations. I know that not all of you have used that. So besides the standard load sets and load combinations in SDC Verifier, it's possible to have predefined from library automatic load combinations when the user just have to define the type of individual load, and combinations are going to be built completely automatically. In terms of this checks, we have improved the speed and performance of this, and we now have Eurocode EN 13001. And for the next version, we plan to add ASCE 7, I believe, ASCE 7 automatic load combinations. So not only building load sets from scratch, but generating in couple clicks full matrix of loading is possible with the latest version of SDC Verifier, and now the speed and performance of this tool has been improved also. For SDC Verifier standalone specific, a lot of performance improvements and graphical improvements have been done. Among the main of them is the improved import of geometry or analysis models. We can import any kind of DWG, DXF, step files, etc. for the geometry, as well as analysis models from Ansys, Femap, Abacus, other interfaces, dot files, and so on. So improved import of geometry and analysis models, and we want to continue on working on that. IFC format is pretty general, so I think that's going to be the next addition in terms of importing of the models. We added the possibility to work with colors for properties, materials, geometries, and so on and so forth. So graphical improvements to the interface that I showed to you at the beginning, as well as we have added the possibility to view the list of geometry items and show height option. So geometries, materials, properties now are subjected to convenient options to either select or deselect something to be shown or hidden, to ease the modeling, to ease the preview of results, and to ease the operation with your 3D model in the independent graphical interface. Possibility also to show and hide contact regions, connections, spider nodes, I believe, RB elements, and things like that. So improvements to graphics, improvements to visual, and to addition to modeling interfaces, as well as importing of geometries and importing of analysis models. Some of the performance improvements I showed earlier to you, the Rainflow Counting tool, and it's now available within fatigue standards. We have also increased the performance of Rainflow Counting tool, so calculations are faster, and project loading time is shorter when you're loading the history for a huge amount of load groups, because when you're working with Rainflow Counting, you're working with the significant list of data in terms of loading steps. Also, performance of optimization tool has been improved and increased. So now the optimization is calculating much faster, especially for plate element thickness rule. So when you're defining the elements to optimize the plate thickness, SDC Verifier is now going to do this much faster. To those who haven't used SDC Verifier's optimization tool yet, yeah, I strongly encourage you to try, because this is a big time saver after the analysis is done. So when you have the results and they are either over the allowable value or too low, and you understand that this is a misuse of material or overuse of the material, SDC Verifier helps you to pick the best design decision based on requirements of the standards. So please head to optimization section of SDC Verifier after jobs and tools, or in the ribbon on top, and try optimizing your designs with our optimization. It's available for 1D elements, it's available for plate stresses, plate thicknesses, weld types, and other variables based, and once again, it's based on code checking results. So it's mapping your variables of a certain portion of the model to give you the best design decision based on standards. So yeah, go get this this tool and see what you can do with SDC in its with its optimization. Bug fixes and improvements in performance. There is a long list of different fixes. It's all available on our website in known issues and fixed issues, as well as in the article on what's new in SDC Verifier 2024 R1. So while you will be downloading SDC Verifier, please head to this what's new section and basically read the text format of what I'm explaining and showing to you today. We have also updated a lot of materials. So besides the fixes to the program, improvements of tools and features and addition of the standards, we have also updated materials. I have shown the extended list of standards to you and the benchmarks for the different codes. But besides this, we have also updated all of our tutorials. So you can see the tutorials are updated with the latest versions, and we have tutorials for, so all tutorials of get started and working with SDC for interfaces with Ansys, Femap, and Simcenter have been updated. But in the same way, the possibilities of the list of tutorials for SDC in standalone version has been extended with modeling tutorials, analysis tutorials, checks, reporting, result presentation, and much more. So to sum up, SDC Verifier in this version has 5 new codes, multiple performance improvements, many different graphical improvements, as well as functionalities for previewing your model. We are working on new standards to, of course, extend that library, as well as we are working on parametric modeling and modeling import and simplification and ease of analysis. On top of all of this, we have significantly increased the performance of the software in general, in terms of speed, for rainflow counting, for optimization, for generation of results, and delivering your calculation results even faster. If some of these features that you have seen today are of your interest, send us a message if you would like to learn more. In the coming weeks and months, we are going to run the dedicated how-to videos, dedicated articles, explanation on how to use it, and extra tools to extra materials to provide you with the best knowledge about the newest features. Also, if you are now is the good time to suggest your ideas and improvements for the next version. We already have a roadmap for SDC Verifier 2024 R2, but if you are missing something, if you would like something to be added in the future versions, now is one of the best times to add this information. So please send me an email to oleg@sdcverifier.com, visit our website, give me a call, and of course, I encourage you to connect with me on LinkedIn. We are posting lots of further updates and improvements and knowledge about SDC Verifier online.